Hi, welcome to IncluIT TechTalk. My name is Diego and I'm with Ezequiel and Maxi from the IncluIT testing department, and we are here to share our experience automating the infotainment system of a car. In the first part, we will give a brief description of the infotainment system we are testing, and in the second part, we will talk about the innovations we develop in order to solve the challenges we face in our testing processes. Now, Maxi will start with the presentation.
Hello you all, this is Maximiliano. The first question we all have when joining the project is, what is infotainment? It may seem a new and fancy word, but the examples of infotainment are not that new. We can think of an old television documentary being a classic example of infotainment, because we get informed and at the same time entertained when the TV show is developing a particular topic. But how is this related to cars? Since some years ago, cars come from factory with a little display. This display is located in the front panel near the driver, and in most cases is a touchscreen device. This display gives the driver and passenger access to some applications such as EM and FM radio, phone application, navigation application, and so on. This whole system that allows to manage those applications is what we call infotainment system.
Hello, my name is Ezequiel. When we start to testing in this project, we have a challenge to test an architecture that have different components and different parts in the vehicle. Our system is composed by different sensors and devices, and all this system interact with the main system that is an Android system. In our case, we have a Android 5.1 Lollipop that is the version of the system that we use to develop the application and in our case to test. Our system and the hardware is connected by a MOST ring that is a protocol that allows send and receive different information through the system card inside. Our system have different applications, and we will explain some of the main applications that we have to test and automate the testing. The applications are navigation, phone, radio, and voice recognition. One of the main features that have this car is the touchpad. As you can see in the slide, this touchpad is a component that allows the driver to manage the system without touch the screen, because the screen is not a touch screen. One of the main applications is navigation app that allow navigate to an address with a GPS and have the interaction with the different parts of the system. One of the parts is the main screen, another part is the screen behind the steering wheel, and we have all these parts integrated and have all the informations about the how to navigate or how to go to a place. Other application that have the system is the phone application. This application allow us pair a phone and make a calls, send message, or reproduce multimedia content in the system without use the cell phone, so we have all the information connected in the system. Also, this application interact with the different parts in the vehicle, like the speakers, microphone, or for example the screen, the main screen, or the screen behind the steering wheels. Another application is the radio. The radio is a common radio, but have a different features additionals like a satellite tuner that allow the driver hear more content than the normal radio, and also have the possibility to reproduce high definition content. And for example, in the main screen we can saw different images and information metadata about the radio content. The last one is the voice recognition application. This feature in the car allows to the driver send commands, voice commands that perform different actions in the vehicle. For example, if I want to make a call, I can say, for example, call Maxi, and the car with the phone paired in the system will make a call without my hands or without use my cell phone. Also have a different commands that allow reproduce multimedia or ask for a direction in the GPS to navigate, or different functionalities of multimedia, phone and navigation.
After this brief description of our infotainment system, we will talk about the approach we follow to automate the test cases. What we wanted to do is to automate test cases. These test cases were run manually, but what kind of test cases are we talking about? Well, depending on the point of view we had over those test cases, the classification we can make of them. In our case, the test cases were all written without seeing the code that we want to test, so all the test cases were black box test cases. We can also classify the test cases as functional or not functional. In this case, the vast majority of the automated test cases are functional. There are few examples of not functional automated test cases. And finally, we will say that the automated test cases are at the system level or integration level, because what we test are sequence of screens into an application and also interaction between applications. For instance, what happens when I am listening to a radio and I receive a phone call, how the audio interacts of these two applications and how the user interface interacts. And how is this framework built? In this slide we have a simplification of the automation framework. In the left, we see the automated test case that is a list of a logical step, such as open phone application, click on a menu, select a submenu, and so on. And in the right, we have our device under test. Thus, in our case, it started being an Android 5 device. In the middle, we have two big actors. One is Selenium, and the other is Appium. Selenium, as you may know, is one of the most used tools to automate test cases for a web server. And here is where Appium takes value, because Appium is presenting the mobile device to Selenium as if it were a web server. This allows Selenium to interact with the mobile device as if it were doing it with a web server. Finally, there is a tool named UI Automator. That is the one in charge of executing the commands over the device, and is part of the Android SDK.
To resolve the infrastructure challenge, we create two servers that have the continuous integration system inside. One of them, in the left of the image, we have the server that build the version of the system that we need to test. After this server build the image, we download with the other server that have all the automated process that allow us install the new version that we need to implement the automated testing. First, our server download the image. After that, install the image in the system. Also authorize the device to allow us connect and perform different actions. And after that, we have also different scripts, for example in Bash and Python language, that allow us be available to modify different configurations in the system. All these actions are performed by the ADB connection and the serial port connection into the device that we are to use for the testing.
At this point, we were able to see about what we have to test and about the infrastructure of the project, but now we are going to start with the innovations we have to perform in order to solve all the challenges we have. The first challenge we have was that we have applications like phone, like Bluetooth audio, and to be able to execute the test cases for this kind of application, we need to link a cell phone with a car. And to be able to do that, we have to create the multiple device manager. This allows us to interact with multiple devices in the framework. To do this, what we have to do was to create an Appium server instance per device in different ports, and this allows us to interact not only with the FCB, with the car, but with all devices connected to the server. In the same test case, we can work with multiple devices. This allows us to automate scenarios, for example, like the phone applications, where we have to check the contact list, recent calls, and we were able to test applications like Bluetooth audio, SMS, and other applications. The problem we have in this moment is that these test cases were semi-automatic, because the pairing, linking the cell phone to the car, we have to do it manually. And that's why we were not able to execute the test cases in the continuous integration. We have to pair the cell phone manually to the car and then run the test cases. And this one was the second challenge we have. What we did was create the auto pairing step. This is a step in that implement and validate if the cell phone was linked to the car, and if they are not, perform all the actions to link the phone with the car system. At this moment, we knew that we were able to interact with one phone and the FCB of the car, and we have everything to interact with more devices. And that's what we did. We start connecting more phones and trying to automate different scenarios. For example, making a call phone. We were connected to a phone that makes a call to the phone linked to the car, and we were able to check if the phone calls appear in the car screen. But the problem was that the framework didn't have the ability to identify which phone was the one linked to the car. That's why we have a new challenge, and we have to create an application, app info device, that the framework install and execute in each device in order to know which device is connected in each port. With this, we were able to identify which was the phone connected to the car. Now, yes, we were able to interact with all the devices and automate more complex scenarios like the one I said before.
Another challenge was automate the voice recognition feature. To perform this, we used a laptop that executes the test cases that reproduce through a speaker the command voice, and it is directly reproduced in the system microphone. So the microphone of the system take the command and process the order. After that, the system have the behavior, and our laptop process this behavior and check and verify if the behavior is the behavior expected.
Other challenge we have was that until this moment we were able to validate the screen of the system, but we were not so sure if the audio was coming out from the speakers. And we have several applications that need this kind of validation. We have USB audio, Bluetooth audio, the radio, and the sound systems. That's why we developed a new feature for the framework that we call audio presence testing. And to do this, what we do is to start recording the audio in WAV format when we are expecting the sound. And then we use a library called MusicG that draw and read the amplitude of the wave to make a comparison with an expected result that we define. And with this we can know if the sound is really coming out from the speaker or not. So at this moment we are not just testing the user interface, we are also testing the audio in the system. Another challenge we have was the one I'm going to explain now, and is my favorite. This challenge we called USB multiplexer. And why we create this? As you know, several cars just have one USB port where you can connect a pen drive with music, you can connect a phone, an Android device, or an iOS device. And we have test cases automated for these three kinds of devices. The problem was that these test cases were semi-automatic because we have to plug the device we want to test and then execute the test cases related to that device. To solve this challenge, we have to develop not only the software, we have to develop the hardware too. And to do this, we use Arduino. So we developed the software in Arduino. And what this USB multiplexer does is, by a command line, we can select which port we need to connect to the car. This allows us to run all these test cases in the continuous integration environment, because when we need to, for example, execute the test cases on a USB pen drive, we just select the port where the pen drive is connected and we start with the execution of the test cases. After that, we just run a command line that switch the port to another device, for example, an Android device, and we can continue with execution of those test cases. This allows us to fully automate the scenarios with different devices. So we were able to run all the test cases at night with no human interaction.
Another challenge was the handwriting simulation. Some application of this infotainment system allows the user to enter text. This functionality is used, for instance, for phone application to search for a contact and then call it. So, in order to search for the contact, the user is able to enter text using a virtual keyboard or to draw in each character of the word. This method to enter text drawing each character is named handwriting. In the first stage of the automation project, all these test cases checking the handwriting functionality were out of scope, but then we decided to overcome this limitation and develop an application that, when installed in the device, is used to generate events as a user does when he draws a character in a touchpad. When the framework uses this tool, we see in the screen the characters being drawn and the system catching the characters. This method is used along all the application, allowing handwriting mode. Another challenge was to compare two images, so the automation team developed an application to compare pixel to pixel these two images. And what we see in the screen is the first version of the tool. This version is manually used and allows us to select the images to compare and then to click in Compare button. What we see in this slide, what we see here is an example of two images being compared. The first two images are being compared and the third one is the result of that comparison. This third image is almost all black except for a little gray area. This is the place where the tool is showing us the presence of a different pixels between the images compared. If we pay attention to that area in the compare images, we will notice that the difference is what we call the next maneuver icon. In one screen, this icon is turned right, and in the other is turned left. This first version of the tool that was manually used was then incorporated to the automation framework with a couple of upgrades. The first one was the ability to compare just a portion of the image, not the entire image as in this example. To implement this, we use two coordinates, one for the starting point, another for the ending point. This way, we set an area where to compare the images. The second upgrade was an allow tolerance. This is used mostly when comparing images in navigation application, because this application receives periodically map updates, and in these updates there are small movements in the map elements, so due to 1 or 3 pixels movement in a street or building, we will have a fail in this case. So we decide to allow a tolerance when comparing images. Typically, this tolerance is around 5%. This automation framework we are talking about takes a screenshot of the device under test each time the test case fails. This is used to analyze what happened during the test execution. To set an example, we can imagine that a test case has failed, and analyzing the logs, we found that the automated test case was waiting the presence of a button. So, what we immediately do is to look for this screenshot to check if this button was or wasn't there, and decide if this is a real bug or not. Well, the last tool we want to present in this tech talk is the video recording capability. It happens sometimes that a test case fails randomly, and after analyzing the logs we still kept in doubt about what had happened during the execution. To put light in these special cases, we played a video camera in front of the device under test, and each time the framework starts the execution of a test case, it also starts the recording of that execution. So any delay between application or in general any abnormal behavior will get captured in the video, helping us to get the root cause in cases of failing test case. And here comes the extra value of this automation framework, because these last 3 items we mentioned, the logs, the final screenshot, and the video of the execution, is the evidence we need to support a defect against the software version under test we have. Okay, this is all we have. So now Diego is going to close the presentation.
Well, the idea of this presentation was to share with you the innovations we develop in order to confront the challenges. This project started 4 years ago, and we still running all the test cases every night. We know that to develop all this innovation, we should have to invest time to do it, but the effort guarantees the quality we expected, and we learn a lot, so that's why we wanted to share with you all this information. If you have any question about anything you saw in this presentation, you can contact us. Our emails are in the screen, so thank you for watching. Bye.